For this video, you do not have a note taker, and anytime you do not have a note taker, you will need to set up your own loose leaf paper to have whatever structure is in the video for your notes. So for the notes and the videos that we provide, we use the 2-column note-taking format. Right, so for those of you who know what it looks like, here's the structure of it. Your title or your heading goes in the top left corner. So this would be square roots and cube roots. And that's what this video will be about today. And then down the left-hand column is where we'll put important information and directions, and on the right-hand side is where we'll put examples and other rules and things that you need to know about. If you wish to put your name, date, and block and any essential questions on the top right-hand side, you certainly can. Right? So for the first thing that we want to do, right, we want to talk about how to graph and order real numbers. So we've already talked about the real number system and all of its subsets. So now you're getting a set of real numbers, and your job is going to be to place them in order on a number line. Right? So you will have to draw a number line if one is not provided, and you will need to place dots and label those points where those numbers should fall. So the first set in our example, all sets of numbers go in braces, which are those squiggly lines. You may be horrible at drawing them in the first part of the year, but by the time we use them so much throughout the year, they will get better and better as the year goes on. So just have patience with yourself and give it a try. As long as it doesn't look like a box or parentheses, you're in good shape. All right, so the set of numbers is going to be the square root of 20, 4.7, 12 over 3, and 4 1/3. So you'll notice in this set of numbers, we have some rational numbers and an irrational number. So that's why these are known as a real number set, because it incorporates both. So from those 4 numbers, they are not in order. So our job is going to be to put them in order and place them on a number line. Right? So before we go to our number line, which you can go ahead and already draw, we need to leave some space underneath, because we can't place these numbers on a number line until they all look the same. And in math, the best thing to do when all the numbers look different or are different types is turn them all to a decimal so that you know about where to place them on that number line. Okay, so remember with your graphing calculator, we are in Desmos. Okay, and remember that you need to hit that keyboard up arrow so that you see your functions displayed. Right, and the square root button. And then the number 20, because you're doing the square root of 20. And you'll notice in the right-hand corner that that's the decimal equivalent, so it's about 4.47. So when we go back to our notes, we want to write underneath the square root of 20, 4.47. You don't need to worry about rounding or place values at this point. Just take a couple numbers after the decimal and you'll be able to see where things go. The next one is already a decimal, and that's 4.7. So if we want to keep everything the same length, then we would have this one as 4.70. Anytime there's no number in the back, you put a 0. Right? And then 12 divided by 3, or 12/3, is a whole number, because when 12 divides by 3, you just get 4. Okay, that's the whole number 4, or 4.00, if we're keeping them all the same. And then for 4 1/3, leave the 4, the big number is always going to be your number in front of the decimal, and then do your division with 1/3 if you don't already know this. And 1 divided by 3 is going to give you 0.3 repeated. So we just need to take and write 2 of them and just put the repeater bar to show that it does keep going. So there's our 4 decimals, and that's going to help us place them on a number line. So if you look, I really don't need anything beyond a 4 and a 5, but I don't want to just put a 4 and a 5 on my number line and squeeze all these dots in between. I want to space them out. So if we're looking at it, I can make this one 4.0 down here, and then I can count by tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 10th one is going to be your whole number 5. So basically you just did 4.1, 4.2, 4.3, and so forth. Right? So what I'm going to do is label every other one. 4.2, here's 4.4, here's 4.6, and here's 4.8. And that way your number line is accurate and it's spread out enough that you can see and place everything in a better way. All right, so the first number we want to put is 4.47, and that's going to be about right here. And you can't just put a dot because there's 4 dots that are going to be sitting on this number line. That is the dot, but you need to label it as the square root of 20 because that's what that dot represents. Don't put the 4.47, right? The original number was square root of 20. All right, for 4.7, that falls right here on this spot. So there's 4.7. For 12/3, or just the whole number 4, that would be down here at the very beginning. And for 4 1/3, 4.33, it's going to be a little bit after that 4.3 part, but not directly on it. And again, put 4 1/3. So by putting them on the number line, you've actually put them in order. There's no need to take extra time and put them in order first and then put them on the number line. Do them as you go, and you'll save yourself time, and it works out the same in the first and second place. All right, so the next thing that we want to take a look at is how to turn certain numbers into fractions. So you're going to need to know how to write repeating decimals as fractions. Your normal fractions end up over tens, hundreds, thousands, etc., and then you reduce it as needed, right? But when you have a repeating number, you can't use that, right? So the example that I want to use so that you have something to look off of is we're going to write the number 0.39 with the repeater bar over the 3 and the 9 as a fraction in simplest form. For every part of this course from here on out, even if it doesn't say in simplest form, it means you must reduce your fractions. You cannot leave a fraction in a non-reduced form and get credit for it. All right, so when you go to do this, you see 2 decimal places, and normally you would put that over 100 because that's tenths and hundredths place, right? But when you have that repeating line, it doesn't work that way. So there's a little saying that I have. If you have a line you need a 9. And that's a little rhyming saying so that you'll never forget it because it's different than the other numbers without the repeater bar, right? So every time you see that repeating line, you need 9s underneath it. Now you just can't put 1. If you have 2 numbers under the line, you need 2 9s. If you have 5 numbers under the line, you need 5 9s. If you only have 1, you need 1 9, right? So that's how it corresponds. Now looking at 39 over 99, that is not in simplest form. Okay, so both of these numbers can be divisible by 3 to reduce it. Okay, and 39 divided by 3 is going to give me 13, and 99 divided by 3 is going to give me 33. So if you were to type these 2 fractions in the calculator, 39 over 99 and 13 over 33, they're going to give you the exact same decimal, but only one of them is the right answer because it asks for in simplest form. 13 over 33 is going to be your final answer. So the key to this is if it has a line, you need some 9s. All right, the next thing we want to talk about is our square roots and cube roots. Okay, so we need to talk about the symbols first. The square root symbol, right, looks like the check mark box, and you've seen that many years now. That's your square root. The cube root is the same symbol, but outside of it is a little 3 as an exponent. Okay, but it goes up in the air, right? So that is known as the cube root, because anything with the power of 3 is cubed, right? So those are the 2 differences. And your calculator, your Desmos calculator, does do both of these, and I'll show you exactly where those are. Okay, but before we do that, we want to talk about some things called perfect squares. And you might have several of these memorized by now. And perfect cubes. Those might be a little trickier for you to memorize. You will have to memorize some later in the year in this course, but for right now, the calculator can assist you. All right, perfect squares are when you take a number and you multiply it times itself. The answer you get is known as a perfect square. So 0 is a perfect everything. It's not a whole, or it's a whole number, so it doesn't always get put in there, but if somebody says, what's the square root of 0, you would answer 0. Most times the perfect squares list always starts with a 1. 1 is a perfect everything. Okay, 1's a perfect square, 1's a perfect cube. It's perfect everywhere. All right, so then after 1 squared, you end up with 2 squared, which is 4, 3 squared, which is 9, 4 squared is 16, and you should know these numbers, so I'm only going to do several of them. 25 is 5 squared, 36, 49, 64, 81, 100, and you could keep going. Okay, now for perfect cubes, it's not just the number times itself, it's the number times itself 3 times. So 1 times 1 times 1 is 1. That's why 1's always a perfect everything. And then 2 times 2 times 2, or 2 cubed, is 8. 3 cubed, 3 times 3 times 3 is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. And you can keep going. On your calculator, if you look at your bottom left keypad, you see the a to the b exponent. If you hit that, see, you have to get a new lineup first. If you hit that, maybe it'll work. Oh, okay. All right, for your Desmos calculator to do cubes, you have to hit, if you're going to do, let's say, 7 cubed, you would hit the 7, and then you would have to hit the A with the exponent of B button, that top right corner right there, and then you would have to hit the power of 3 because we wanted to say 7 cubed, and then in the bottom right corner it tells you the answer is 343. Right, so you can raise a number to a power. It's going to use that A with the power of B button on your calculator. And I can show you that more in class if that's not something you feel extremely comfortable with yet. All right, so back to where we were. Now that we've talked about perfect squares and perfect cubes, we want to simplify and evaluate some. So this is the part where the calculator becomes your best friend and you use it more frequently. All right, so the next part is going to be to simplify roots. When it's a mixture of square roots and cube roots, they just call it roots in general. Okay, so some examples for you to look at is if we have the square root of 4 over 121. Now, in your calculator, do not type in the square root of 4 divided by 121. There's a much faster way to do this, and you really don't even need the calculator. Right? If you are looking at a problem like this, if you can stop and break it up, because both numbers are under the radical sign, so that it looks like square root of 4 over square root of 121. Both of those are perfect squares, and you should technically know what their square roots are, but if you don't, you can use the calculator. Square root of 4 is 2, and square root of 121 is 11. So your answer to this problem is the fraction 2/11. A decimal answer will not be accepted because it was given to you in fraction form to start with. Okay, there are certain times where decimals are okay, and there are certain times where they are not accepted for valid answers. Even though they might mean the same thing, they are not represented. Okay, so the fraction 2 over 11 would be your answer to that one. Example number 2, if I gave you the cube root of 1,000. Okay, now if you go to your calculator and you go to, you first have to hit the next line on the left. If you go to functions and then you go to miscellaneous tab on the top right, you will see 1, 2, 3, the fourth one down under that miscellaneous word, right, is the button that allows you to change what kind of root you're doing. So if you hit it, it looks like it's blinking on the outside. That's where you would put the 3 to represent the cube root. And then you type or you tap underneath, and now you need to enter what you're trying to find the cube root of. We wanted to find the cube root of 1,000. So you enter 1,000, and then in the gray box on the bottom right of that corner of that screen is the answer 10. The cube root of 1,000 is 10. Okay, so it's really going to come down to you practicing using the Desmos calculator to get used to it in the first place, as well as understanding what you're doing and how it looks. All right, so the next one is going to be the cube root of 180. So we're back in the calculator again. You got to hit a new slot below it. Okay, and then remember that your cube root button is under functions, under miscellaneous, fourth one down. Then you have to hit the 3 to represent the cube root. And then underneath the radical, you want to put 180. And you'll notice that it comes out to be a decimal, right? You don't need to write every single part of that decimal down. Okay, typically the directions are going to tell you where to round to, and if they don't, just round it to the tenths place. Tenths or hundreds is fine. So for the cube root of 180, it's about, because it's not technically equal to, but it's about 5.6. Okay. Okay, and then the last section that we'll be looking at is estimating, which means you're not going to give an exact answer. You're going to be rounding. So this puts your rounding skills into place. And you're estimating to the nearest whole number. All right, so with this one, I've got 2 examples to show you. So the first one is going to be the square root of 35. And we know 35 is not a perfect square, so we know it's going to be a decimal, right? But we don't want the decimal value. We want about what it's going to be to the nearest whole number. So again, hit your next arrow down or your next spot underneath where you were. Square root is on the left and the keypad on the left, and then 35. And the trick with rounding is if the number right behind the decimal, this tens place right here, if that is 5 or higher, you are going to round up. So because it's a 9, we're going to bump the 5 up to a 6. Okay, so for this one, the square root of 35 is about 6. Okay, for the next one, I want you to practice estimating to the nearest whole number with a cube root. So we're going to do the cube root of 90. Again, we're going to go back to the calculator. You've got to hit the next spot down. Okay, let me get rid of my little arrow here. You're going to go to functions. You're going to go under the miscellaneous, fourth one down. You're going to type in the 3 for the cube root part. And then we want to do the cube root of 90. So we got to type in 90 now. And then you see the decimal. Again, you want to look at that number right behind the decimal, and that's going to tell you whether you round or not. Don't worry about any of the other numbers behind it. You don't keep bumping things up just because there's more numbers behind it. That 4 is going to tell you what to do with the front 4. So because that 4 is under 5, then the front 4 stays exactly what it is. Right? And another way to look at it is like money. If this were $4.48, would it be closer to $4 or closer to $5? Well, it's closer to $4. So if a number's 5 or more, you bump up. If it's 4 or less, then you keep it the same. So for the square or the cube root of the cube root of 90, it is approximately 4. Right, so we'll be working more with this in class, and you'll get used to using these calculator buttons. Play around with them and see what you can get familiar with, because it does just take some practice. Okay, and we'll see if there are any questions when you come to class.